I'm sitting here in the dark because I wanted to illustrate just how dependent we are on electricity. Most of us are able to access electricity with just a flick of a switch. So most of us are completely dependent on electricity to go about our daily lives. We use it to heat our homes, we use it to cook our food. At the moment, lots of us use it to drive our vehicles around. And every single one of us has got a huge array of devices which we have to power up, otherwise we can't go about our daily lives. The big issue is it's easy to think that electricity all comes from green sources such as wind turbines or solar panels. But the reality is that two-thirds of electricity generated in the world today still comes from burning fossil fuels. And that's a huge problem because they produce a huge amount of greenhouse gas emissions, but also the pollution from coal-powered and gas-powered and oil-powered power stations kills people every year. So there's actually a direct human cost to you powering up your devices, which most people don't consider. Actually, moving to electric power is a huge problem because at the moment the grid won't be able to cope with all our future needs. So we need more electricity, we need a better grid, we need better storage, and we also need greener supplies of electricity. So it's a multi-dimensional problem that we have to solve, and I think simulation and test is going to play a huge role in that. It's difficult because I think most people believe nuclear power is dangerous because of the huge impact of events like Fukushima and Chernobyl, yeah, which obviously disrupted loads of people and caused a fair amount of death. But if you compare the death per terawatt hour of energy or electricity provided by nuclear with that provided by oil or gas or coal, the nuclear losses are really, really small. So I don't think that nuclear, compared with the amount of energy that it provides, nuclear power isn't particularly dangerous. But there's a lot of hysteria that surrounds the subject and lots of knee-jerk reactions. So CFD has always been used in the safety case for new nuclear reactors, and it's increasingly becoming the technology which the licensing of nuclear reactors depends upon. So you can't build a new nuclear reactor without doing extensive simulation because you can't test these things. They're huge and they cost a massive amount of money to build a prototype. So you have to do most of the safety work up front. And I think simulation will continue to play a huge role in that. But whether or not it will convince people that nuclear is safe, that's a completely different question. I think hydrogen is part of the answer, but it's not the whole answer. Hydrogen advocates will say, oh, you can burn hydrogen without any CO2 emissions. You can use hydrogen in a fuel cell to electrify cars and trucks and vans. The problem is that there's not much green production of hydrogen in the world at the moment. Over 90% of hydrogen production, I think, is from fossil fuels. And so basically all you're doing is using fossil fuels to make a different fuel and then burning it, which isn't very efficient. There are ways of making green hydrogen using electrolysis from maybe wind turbines or solar powers, but at the moment those processes are too expensive and not done on a large enough scale. And then there's a whole problem of storage and transportation as well. I think there's things we can't electrify, so it's difficult to electrify huge things like big container ships or aeroplanes or trucks. And for those things and some industrial processes like perhaps making steel or making cement, hydrogen will be really useful for those things, but we need to save it for those things and not waste it or the little amount we can make at the moment on things like cars, which we can use standard electrification for. So yes, it's definitely part of the solution, but it's not the whole solution.